Video here on algebraic substitution. This video is actually twofold. I'm going to go over two things. I'm going to go over algebraic substitution. It shouldn't take too long, and then I'm going to go over some type of technical Riemann sum stuff as well following this. Okay, so let's start with algebraic substitution. So algebraic substitution is just a u-sub technique that we can use. And let me just dive into it, and I'll kind of show you what the difference is for any of that. Okay. Ooh. Okay. So for this problem right here, there is no formula for me just to integrate, so I do need to do a u substitution. So I'm going to let u equal 2x minus 1, which is going to give me that du is equal to 2 dx. So I'm going to get 1/2 du equals dx. Now there's a little problem here. I need to cancel out x dx, but I don't have x dx. I only have dx. So I need to figure out a different way to get rid of x. Okay, so let me just kind of write this out where I'm at right now. Oops, sorry. So I'm going to integrate. So this is going to change into u, and then I'm going to have my du. But for this x right here, what if I were to play with this a little bit and I said that, well, 2x is equal to u plus 1. So that would make x equal to u plus 1 all over 2. So I'm going to take that x and now change that into this right here, into this u plus 1 all over 2 du. Now everything's in terms of u, and I can go ahead and use a little bit of algebra here, and then I can easily integrate. So I'm going to pull out that 1/2 out in front, integrate from u to the 1/2, change it to u plus 1 du. Sorry, ooh, this was sideways the entire time. Okay, so it's going to look like this. All right. So again, did my u sub. In order to get rid of this x, though, I had to play around with my u a little bit, so I made x equal u plus 1 over 2. And then did a little bit of algebra to rewrite it like this, and now I'm going to distribute this onto both of these terms. So I'm going to be left with 1/2 u to the 3/2 plus u to the 1/2 du. So here we go. I'm going to go ahead and find the antiderivative of both of these. So this is going to be u to the 5/2 divide by that, which is 2/5, plus this is going to be u to the 3/2 divide by that. It's going to give me 2/3. Plus c. And then the only thing I have left to do here is just replace that u with my original. So I'm going to get 1/2, 2/5 of my 2x, should be a minus 1. I have an eraser here because it's a marker, to the 5/2 plus 2/3, 2x minus 1 to the 3/2 plus c. Now you can distribute that 1/2 if you want to in there. I'm not going to worry about it, but there you go. So that is algebraic sub. Oh, I just noticed something. I'm gonna fix it real quick. I forgot this 1/2 part right here. So that should be a 1/2 in front, 1/2 times that, 1/2 times that, 1/2 times that, 1/2 times that. So I'm glad I caught that real quick. All right, so I forgot my 1/2 du. I was getting so excited about the algebraic sub. So don't forget that 1/2 that carries in front the entire time. All right, I'll simplify this now to make it look nice. So I'm gonna get 1/4 times 2/5, 2x minus 1 to the 5/2 plus 2/3, 2x minus 1 to the 3/2. And then if I distribute that in, I'm going to get 1/10, 2x minus 1 to the 5/2 plus 1/6, 2x minus 1 to the 3/2 plus c. Good thing I caught that. All right, next problem, super similar. Okay, I'm going to do my u sub. Obviously, I have to do my u sub underneath the radical there. So it's going to give me u equals 1 plus x squared So du is going to equal 2x dx. And I'm going to move that 2 over to be 1/2 du equals x dx. Now I need 5 of these x's. I only have 1 of them. So what's going to end up happening here is, well, let me do a quick rewrite of this before I actually do my u substitution. It's going to give me x to the 4th times x dx. So clearly I'm going to get rid of this x dx, change that into 1/2 du. This 1 plus x squared is going to go away because it turns into u, but what about x to the 4th? Well, that's where I can go ahead and do a little bit of work here. Well, isn't x squared equal to u minus 1? So if I square that again, that'll give me x to the 4th. So now I'm ready to go for u sub here. So I'm going to get square root of u, okay? And this is going to turn into u minus 1 all squared. X dx turns into 1/2 du. Put the 1/2 out in front like that. And I'm just going to double check my work just in case I forgot something. Nope, we are good to go. So now I just need to do a little bit of algebra here. So before I integrate 1/2 u to the 1/2, if I expand u minus 1 squared and distribute all the way through, I'm going to get u squared minus 2u plus 1. And then now I'm going to distribute that u to the 1/2 all the way through. So I'm going to get u to the 5/2 minus 2u to the 3/2 plus u to the 1/2 du. And now I'm ready to just go ahead and find my antiderivatives of everything. So this is going to give me 2/7 u to the 7/2 minus 2 times, this would be 2/5 u to the 5/2. I'll clean that up. Make sure you know that that's a time sign. Plus 2/3 u to the 3/2 plus c. And just going through, doing a little bit of cleanup here, I'm going to get 1/7 u to the, I don't know why I put that in parentheses, u to the 7/2 minus 2/5 u to the 5/2 plus 1/3 u to the 3/2 plus c. Plug my u back in. This is why I put it in parentheses. I did not want to plug in right away. So 1 plus x squared to the 7/2 minus 2/5. 1 plus, forgot my squared there. 1 plus x squared to the 5/2 plus 1/3. 1 plus x squared to the 3/2 plus c. Woo! Calculus difficulty, not much. It's just really just carrying this all the way through. Just making sure you don't make any algebra mistakes, which is really the only thing that can happen here on algebraic substitution. All right, last one. This one's just a definite integral. It's no different than the other problems we've been doing. We're just going to combine u sub definite integral stuff with what we're doing right now. So I'm going to let u equal 2x minus 1. That's going to make du equal 2 dx. So half of du is equal to dx. Again, I'm going to have this x left over. So, well, what is x? Well, isn't x equal to u plus 1 all over 2? Just double checking myself here because I'm kind of going fast. Yeah. So, integrating, I'm going to have this 1/2 out in front and that 1/2. So I'm going to have 1/2 times 1/2. So that 1/2, this 1/2. This x just changed into u plus 1. And this changed into root u on the bottom. And then this is du. Okay, bounds. Let's go ahead and do that. So if I plug in a 1, I'm going to get 2 times 1 minus 1, which is 1. Oh, that's super convenient. If I plug in a 5, I'm going to end up getting 2 times 5 minus 1 is a 9. So 1 to 9, which is nice. I do not need to convert this back now. I'm ready to go. So I'm going to get 1/4. This is just all rewriting at this point. It's going to be u to the 1/2 plus u to the negative 1/2 du. It's all I did was rewrite this as this right here. So I divided the u by square root of u and the 1 by square root of u. So I'm going to get 1/4. I'm going to get 2/3 u to the 3/2
plus 2u to the 1/2. Evaluate that from 9 on top, 1 on the bottom. So I'm going to go ahead and plug that in. So 1/4 of 2/3 times 9 to the 3/2 plus 2 times 9 to the 1/2 minus, running out of room here, so 2/3 times 1 to the 3/2 plus 2 times 1 to the 1/2.
Okay, just go through all that algebra, and you're going to get 16/3. I don't want to waste your time on all this algebra because I don't want to make this video too long because we're only halfway through here. Again, pretty heavy in the algebra. I went fast with the algebra, so if you're not comfortable with it, slow it down, take it step by step as you go through. Okay, so that's the algebraic part. Now, I do just want to cover a little bit more Riemann sums because this can be a little bit complicated. The technical definition of Riemann sums. There's a reason that I've kind of saved it. I didn't want to just scare you off right away with technical definition. So here it is. So you can kind of read through here. What really is telling us about Riemann sums is to find a definite integral, it really is going to come down to this right here. So this little integration stuff is the same thing as a summation. Okay? So the integral from a to b of f of x dx is equal to the limit as n approaches infinity of the series. S stands for series. So which is the same thing as limit as x approaches n as we do this. Holy cow, this looks kind of weird. This is the sigma notation, which means you're going to keep adding all of these over and over and over again. So what this means is when we do a regular Riemann sum, we're estimating because we have rectangles of like set thickness of like, hey, it's the width is 2 and whatnot. What this is doing is just saying, hey, let's make our width as tiny as possible and let's add all of those together. So that's what this definition means. So the important things that we need to know are right over here for formulas. Okay? In terms of right endpoint, in terms of left endpoint, and what delta x means. We're always going to do right endpoint because you're going to end up getting the same answer for right and left endpoint anyway, because we're adding an infinite amount of these. This one, the right endpoint one, is a little bit simpler. Okay, so what's pretty big here is just to kind of note of translating this stuff into here. So this delta x is really going to turn into this b minus a, and that's going to be our bounds. B is our upper bound, a is our lower bound. Okay, in the c part is just whatever the function is. Okay, so let's go ahead and use this information to rewrite the integral from -2 to 1. So we need to find out what delta x is first. So delta x is going to be my b value, which is 1, minus my a value, which is -2, all over n. So this is going to give me 3 over n. Okay? And now I need to know what my C1 is as well. So my C1 is my lower bound, which is -2, plus, and this is going to be I, change in x. So this is going to equal -2 plus 3i over n. Now, I is not like the letter I as an imaginary. I'm just using it. Well, they use k in this formula right here. You can use k or I. It doesn't really matter. A lot of times they'll go ahead and use i's, so that's what I do. So that's what that is. Okay? So now let's go ahead and plug this in. So this is going to be the limit n approaches infinity of this summation from I equals 1. You could use k instead of I. Again, you just need to change that one right there to a no, it was off the screen. Change that one to a k. So we're going to go from I equals 1 to n of our function of ci delta x. Okay, so what that's going to turn into, let's go ahead and translate this. So n equals 1. So my function here is going to be 2 times x. So it's 2 times, well, what is my function? It's just x. I'm just going to plug this in. -2 plus 3i over n. And then delta x is just going to be 3 over n. And that's it. That's how you translate it. You don't need to ever solve it from this way, but AP will sometimes ask to go from here to here. And that's all you do. Could you simplify this a little bit further? Yeah, you can multiply the 2 times the 3 and make that a 6, but this would never be a free response. It hasn't been before. It would just be a multiple choice. Okay. More likely, they're going to ask you to go from this form back to here. So let's go ahead and do that. So we kind of have to use our context clues here to figure out what my delta x is going to be. So let's go ahead and do it. So this is the same thing as, again, delta x times, here's my first function, plus here's my second function, plus dot, 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 and this is my nth function. Okay? So it's just going all the way to my nth function. So with that being said, well, I only care about my nth function because that's what my definition uses. So this is going to equal f of whatever a is plus I change in x. Okay? Well, I guess it's not I. I guess it's n, because they're saying that that's c sub n. So, okay. So let's go for it. So this is going to be f of 5 plus n times 3 over n. So I'm just taking this and I'm translating it to here. So it's 5 is right there. The n, I'm just putting it out in front, and then it's 3 over n. Okay, so what does this mean? That means that a is 5. So what is b then? If a is 5 and my change in x is it's a change of 3, that means since I'm changing it to 3, it's going to be 8. Okay? So when I integrate, I'm going from 5 to 8. And what's going on to all my functions here? Being squared, it's being squared, it's being squared, everything's getting squared, so it's just going to be x squared dx. All right. To be honest with you, this is probably the most complicated thing you will ever learn in this course. It is rarely asked, but I do want to make sure I do cover it. So all I'm asking you to do is really just know how to go from here to here, or how to go from here to here. Okay? So here is an actual AP question from many, many, many years ago. So let's go ahead and tackle this together. So as we're looking at here, again, this is going to be our delta x times, that's my first function, plus there's my second function. Do I really care about those? I do not. Plus my nth function. Do I care about my nth function? Yes, I do. So here we are. So f of c n equals f of a plus n change in x. So what does this give me? Well, since there's no a value, a is 0, so this is going to give me f of 0 plus n times 3 over n. All right. So since this is n all over n times 3 over n, this means that my change is going to be 3. So if my a is 0, my change is going to be 3. So I have to look for bounds from 0 to 3, which means that we can already eliminate choice A and choice B. Okay? So now what's going on to my functions here? Everything's being squared. So my function is just getting squared. So I'm going to end up getting from 0 to 3. Every single function is getting squared, so it's going to be x squared dx, which is going to match choice letter D right there. Okay? So again, this stuff is a little bit more intimidating. It's a little scary. You can call them scary Riemann sums. This is really all we're going to be talking about it. You're not going to see it very often. It might be, you might hit it up on a random quiz, random test, just to see if you know what's going on. But that's it. Just being able to translate from here to here is all I'm asking you to do. And it's really just using these formulas right here. We're really just the right endpoint and then the change in x. You're just going to look at that nth term and then find your a value, find what your b value is and what's going on to each term, and then that would do it. All right, and that's all for this video.